Hello! Today in the lesson we will solve more examples in which we will write the union and intersection of numerical intervals. But I'd like to point out in which examples we're going to apply in the answer and write the union or intersection. The thing is, in math, we solve inequalities with absolute value. For example, if I write down the following inequality, x plus 3 is greater than or equal to the number 2. Well, then when we solve that inequality, which is written using an absolute value, we will apply the union of number spaces. And if I were to solve the inequality x plus 3, which is written in modulo, but it will be less than or equal to the number 2, then in this case I will write the intersection in the answer. So let's solve the first inequality where the absolute value of the expression x plus 3 is greater than or equal to 2. In this case we need to make a set of two inequalities. Aggregate. This sign denotes the aggregate, but most importantly, this sign means that in the answer we will find the union of the resulting numerical intervals. So how do we solve this inequality? First of all, we must remove the absolute sign and write that x plus 3 will be greater than or equal to the number 2. And in the second case, we write that the number x plus 3 must be less than or equal to the number minus 2. And then by solving this set, and in particular separately each inequality, we will get the following answer. The set of the following answers. X is greater than or equal to 2 minus 3 is minus 1. And in the second case, x is less than equal to minus 5. And then in order to write down the final answer, I have to show the solution to the first inequality. The solution to the first inequality is all the numbers that are greater than or equal to the number minus 1. I'm labeling all values that are greater than the number minus 1. And in the second inequality, I have to show the solution to the second inequality on the same coordinate line. And in this inequality, x is less than or equal to minus 5. Minus 5 is to the left of minus 1. And all values of x that are less than minus 5 will be to the left of the number minus 5. But in order to write down the answer, I note that this is a set of inequalities. In the answer, I have to write down the set of numerical intervals. In order to write the aggregate, I must write the union of the resulting numerical intervals. And on the coordinate line, I write the intervals from minus infinity to minus 5, and from minus 1 to plus infinity. That will be our answer. So if I take any number from these two intervals and substitute it, instead of the variable x, then I have the following condition. Now, the expression will be greater than or equal to the number 2. Let's take a look at one of these numbers with you. The interval from minus infinity to minus 5 belongs to the number minus 10. Let me write down the number minus 10, and we're going to check this number. In our original inequality, instead of the variable x, I substitute minus 10. Minus 10 plus 3 must be greater than or equal to 2. Minus 10 plus 3 is minus 7. But modulo the number minus 7 is just the number 7, and it is greater than 2. As a result, the number minus 10 is the solution to our inequality. In the same way, I can choose any number from minus 1 to plus infinity and substitute it into our inequality. You can check this for yourself. But when we solve the inequality x plus 3 modulo less than or equal to 2, in this case, I write the intersection in the answer. And then I'm going to combine that into a system. As a result, I write x plus 3 will be less than or equal to 2. But at the same time, x plus 3 will be greater than or equal to minus 2. And then solving that system, I'll have x is less than or equal to minus 1. But in turn, x is greater than or equal to minus 5. And then on the coordinate line, I show the solution. X is less than or equal to minus 1. These are all the numbers. Less than minus 1. And x is greater than or equal to minus 5. These are all numbers that are greater than minus 5. Notice that I label these intervals like this in order to see where I have an interval where I have numbers that satisfy both the first inequality and the second inequality. That's the interval from minus 5 to minus 1. Then in the answer, I write down the intersection. And then I'll write that x belongs to the interval from minus 5 to minus 1. If I choose any number from that interval and substitute in our inequality, the result is a true statement. In the next lesson, we're going to use the union and intersection of intervals to solve inequalities. For today, our lesson has come to an end. Goodbye, see you again.